Pushkin. So the part we already know is this. We need to stop taking carbon that's stored in the ground and putting it into the air. We need more solar power and wind power and batteries and electric vehicles. But it's pretty clear at this point that all that is not going to be enough. We are not going to be able to decarbonize fast enough to avoid a really bad climate outcome. At some point, we're going to have to figure out how to do more. I'm Jacob Goldstein, and this is What's Your Problem? The show where entrepreneurs and engineers talk about how they're going to change the world once they solve a few problems. My guest today is Shaun Kinetic. He's the co-founder and chief scientist at a company called Charm Industrial. Charm is fighting climate change in a giant but kind of overlooked corner of the economy, agriculture. Shaun's problem is this. How do you put billions of tons of carbon back into the ground? So think about giant industrial farms. Fields of corn and wheat and soybeans absorb billions of tons of carbon dioxide from the air every year when they grow. So far, so good. But then, once the crops are harvested, the leaves and the stalks decompose, and they send a lot of that carbon back up into the atmosphere. Damn. What Shaun's company Charm is trying to do is grab that carbon before it goes back into the air. To do that, they go out into the fields after the harvest, chop the leaves and stalks up into tiny pieces, and heat those pieces up super fast to around 1,000 degrees Fahrenheit. This turns the carbon in the plants into this thick, oily substance called bio-oil. Then Shaun and his colleagues stick that bio-oil back into the ground where it stays more or less forever. It's a complicated process, and right now, the company is trying to build the machinery that will make all this happen. To start with, Shaun gave me the dream version of how it's all going to work.
A giant piece of farm equipment that will roll onto the field and it will pick up portions of what are left over in the field as agricultural waste. And it will process that into oil and offload it into a tanker. And our entire built world is designed around moving oil. And so the infrastructure already exists, the know-how already exists. Once we generate this oil, then we can move that into the network that already exists to get that oil removed from our biosphere.
So that's the dream, but Shaun and his colleagues have to solve a lot of problems to get there. They don't yet have a machine that can drive around the field on its own. They have a couple big stationary machines designed to sit at the edge of a field. And early this year, they shipped those machines out from their headquarters in the Bay Area for their first big test. A lot of things went wrong, but that was kind of the point.
It was 2 semi-trailers. One was for biomass preparation. It was just about getting the bales down to the sawdust that we need to feed into the machine effectively.
Okay.
And then the other shipping container was just the machine itself for producing the bio-oil. And so they were both up on trailers. Trucks came in, picked them up. We waved them out.
Okay.
And then we met them in Kansas.
And so did you, in fact, get on a plane and drive out to the farm and watch the truck pull in with your containers full of machinery?
We thought we would be there to watch the truck pull in, but it turns out that interstate trucking is way faster than we anticipated. So it got there before we did.
You should have just rode along in the truck.
I know, it would have been the best way. We actually, my partner and I were driving out to chase it, and we ended up getting stuck by a blizzard in Utah, and the truck just went through fine. So it was quite the adventure to get there. And then once we got there, it turns out that what we were trying to do with this was learn about the deployment. We were trying to learn about what it takes to operate this machine actually on the field edge, away from our machine shop, away from our CAD stations. What does it take to really be in an RV on the side of the field running this massive thing we had built? We had to bring all of our tools with us. We had to bring all of our spares. We had just an enormous amount of infrastructure that we had put in place to be ready to run. And I mean, fundamentally, I think we forgot about winter as a concept. And so that was the first mistake. We had spent too long in California.
Yeah, okay. Yeah. That's a big problem.
We got there and our air compressor was like, no, it's too cold for me to start. And we're like, oh. So it begins with that. And then our nitrogen plant had basically a water removal system on it that froze solid. We had there's ice building up. We got snow on the machine. We had ingress of water into all different pieces that we hadn't expected after running our prototype basically in the Bay Area, which is namely doesn't have winter. So it was these little things that were like, of course we were thinking about this when we were designing. We knew the conditions that would be in Kansas, but when you're there in negative 10-degree weather with whipping wind on a machine trying to remove a component, it is just an entirely different experience to be there. And I think that was what we were trying to show our team was it wasn't about getting the first prototype up and running perfectly. It was about doing each step of our process, verifying it end to end. And we learned so much in that. And so we were learning every day, and the team was getting back and we were all cooking dinner for each other. And really there was a sense of like camaraderie and adventure, I think, among the team. And
I mean, I like the camaraderie and adventure. How much of that is like the retrospective warm glow? How much at the time was, oh my God, this isn't going to work?
The adventure was real in the first, I think, couple deployments. And then the darkness set in probably in February and March. There was a tornado nearby. We had all sorts of exciting things happening in Kansas that were, not abnormal for Kansas.
Let me ask you a simple question. And I know working, not working is not entirely binary, right? It's like, how efficient is it? How long does it take? But how long did it take for it to work?
We were up and running probably about a month after we got to Kansas. We got the machine up and running. It ran its first, what we call hot flow, where it was getting material through the machine. And so that was when it was like, all right, we're here, it's working. Now we have to try to optimize each part of it. And so we were basically every time we would run the machine, we'd be like, okay, well, here's something that's not working as well as we'd like it to. What can we put in place so that it will run longer for the next time, or that will run more efficiently the next time? And so we were constantly trying to basically upgrade the machine. That's what my partner Kelly and I at Charm do, is we lead the sort of rapid iteration of the hardware. And so that's what we were trying to build.
In a way, it's like the way people make software, right? Like you're doing the minimum viable chemical reactor that can sit on a field in Kansas and then trying to iterate, right? Like that's basically what's happening.
Exactly. Kelly and I were at a company called Planet, where we were working on the Dove satellite.
We had Will Marshall on the show. Shout out to Planet. Yeah.
Shout out to Planet. And I heard Will talking about this on the show as well, where he mentioned this sort of like 10 to 20% target failure rate of the satellite. And so we were constantly trying to get new features in and get new functionality in, and always pushing that envelope.
This is interesting. So the satellite industry is a model, right? It's the story you're telling is the same story that people like Will Marshall from Planet tells of, like coming into this industry that has been slow to evolve, where things are very expensive. They're manufactured to be perfect and they're super expensive. And you're trying to do the opposite, to make things cheaper and faster and better, right?
Exactly. We say, all right, before we turn it on again, what are we going to upgrade? What are we going to fix? How are we going to move towards our goals?
Let's go back to Kansas for a sec. I feel like I want to sort of finish that story, right? So you're there, you're iterating, you're fixing, you're building. And so did you, in fact, do the whole process for real with this machine in Kansas?
Yeah, we produced bio oil with our machine in Kansas. And we took in a corn stover bale and processed it through to bio oil. And did we process the entire 2 million pounds of biomass that we had like staged in the background in the event that we were running at 10 tons per day at full rate? No, the machine, I think we operated at peak of about 3.5 tons per day.
One last detail about what actually happened there. What'd you do with all the oil you got from the corn stover?
We put it back underground.
Where?
In wells in Kansas.
Tell me about the oil that you get out of agricultural waste. Like, what is it like? Is it like the oil that comes out of the ground? Like, what is it?
It is like oil in name only, unfortunately. You know, if you've ever had fake wood smoke flavoring, that is bio oil. It's the exact same stuff.
Liquid
it's used as
smoke?
a food additive. That's it. We make liquid smoke under a different brand name, obviously.
And can you? So it smells kind of nice, maybe a little strong, but like kind of sweet, smoky sweet.
Mm-hmm. Yeah, it smells like a campfire. I mean, that's the smell of it.
Can you taste it? Have you tasted it?
I wouldn't taste our stuff. It's, I mean, basically, I actually have lost the taste for fake wood smoke flavor as well. I can
You
taste
know
it
too much.
in
You know
food, and
too
I'm just like,
much.
no, I
Yeah.
don't want this. So it is. I mean, I don't want to sugarcoat the like. I don't think anyone should go out and drink this stuff in the same way that I don't think people should go and drink and be around crude oil. It is
Yeah.
a messy, dirty substance, and so I think that the we we sort of look at charm in the way that it took this, gross oily industry to get us into this mess. And I think it's going to take a little bit of a gross oily industry to get us out.
Is it sketchy injecting oil into the ground? It sounds like it could be sketchy.
There are absolutely risks with injecting anything underground. And I think that the ways that you mitigate that are through careful analysis. You look at the confining layers, and you look at formations that have previously held oil and gas. The Permian Basin held oil and gas for 300 million years. So there are confining formations where the injection of oil will maintain within that formation or within
Wow.
specific well types that are held there. But most of the hazardous chemicals or anything else that this civilization generates is disposed of in these deep underground injection wells.
It's weird. I'm thinking normally at this part of the interview, I'm like, tell me one problem you're trying to solve. But I feel like you have too many problems, right? Like, I
Oh,
feel
we have
like
so
it's
many problems.
everything.
Oh,
Yeah.
that's the wonderful thing about startups is you have usually a considerably more problems than people. And I think that's always the space where I enjoy to operate is at a
But I feel like you're really, I mean, it's true for a lot of startups, but it's really true for you, right? Like, I feel like you guys are so early and it's so hard what you're trying to do. And it's so physical and there's so many things that you have to optimize so much more than they are now. No? Or am I underestimating you somehow?
I think there are solutions in each of these spaces. So there's solutions for char removal. There's solutions for oil condensation. There's solutions at each of the interfaces that we're trying to optimize for. And one of the things that we know from our prototype is that this isn't a scientific problem, right? We don't have to develop anything novel to solve these
Uh-huh.
problems. It's really an engineering problem at each of these interfaces.
So I know one of the sort of sub problems you're trying to solve is how do you power your system? And I know you have this idea that you can use the heat that you get from processing the corn stalks or whatever, the bio waste, to actually power most of the work you're doing, which is a super elegant idea, but it seems really hard.
That is it is a hard thing to do, and we're working with some brilliant people in that space who have a solution for it. And so I think one of the great things about this sort of energy renaissance that we're in right now is that we don't see charm as being the one solution to the entirety of the climate problem, right? And so we are trying to work with a couple groups to generate the power off of our machine because the number one rule of engineering is don't. If you have a group that already is working on this problem and already has a solution in the space, work with them to help shape that into the device that you need for your system.
And is there, in fact, somebody who's like, oh, you need to get power from heating biomass? Good news, we figured out how to do that. Is that the case?
Not only is that the case, but they're in the Bay Area and they are wonderful people.
Oh, great.
So they were by the other night for a happy hour, and we were just like standing by the machine having a beer, saying like, where should we put this port to properly interface to your machine? What is the data that you want from this to ensure that we can, test this, and how can we help you move faster so we can, as a whole, move this industry further along?
So that's the technical side of how charm works, or at least the dream of how it's going to work. But charm is also a business. It's a company with paying customers. After the break, what exactly does charm sell? And who does it sell it to? And now back to my conversation with Shaun. So it's interesting to think about even like, what do you sell? Like, what is the thing you're selling and who are you selling it to?
So we sell a permanent carbon removal, which is effectively a carbon credit for CO2 extracted from the atmosphere.
There's a few things that are interesting to me there, right? One is, so there's this idea of carbon offsets. And clearly what you are doing, if you can figure out how to do it at a reasonable price, right, is real, right? You're taking stuff that would have gone into the atmosphere as carbon dioxide and putting it in the ground approximately forever, for as long as we care about. There are other kinds of carbon offsets that seem more slippery to me, right? Like, I have a tree in my backyard. If you give me $100, I won't cut it down, right? Like, which is, a little bit of a parody, but there is this universe of carbon offsets that have been kind of like that, right?
It's like a hostage situation. Yeah.
I would hate for something to happen to this forest in my backyard.
Yeah, exactly. And it's like there are, and I don't want to undercut like the amazing work that some groups are doing for like habitat restoration and, the co-benefits of having these forestry projects. And there are people doing good work in the space, but there are also an enormous amount of groups that get credits for, the hunting lodge. The forest on the hunting lodge is one that popped up recently. And
like, to be clear, a forest that nobody was going to cut down, right? Somebody's saying, give us money and we won't cut it down.
Exactly. A forest that was not at risk.
Yeah.
Yeah, exactly. And there are, in the same vein, I have friends who are farmers and they get messages that say, we are interested in selling carbon credits from your farm. You may not have to change anything you're doing right now.
Yeah.
And that is just fascinating from a market standpoint. And so I think that what Charm really tries to set ourselves apart on is that our carbon removal is permanent.
It's permanent, and it's pretty clearly carbon that would go into the atmosphere in the absence of you sticking it into your machine and turning it into oil and stick it in the ground, right?
And it is extremely easy to measure. So we can measure every carbon atom within that tote of bio-oil, and we can measure exactly how much mass was injected into the well. We have a measurable pathway.
I think I heard it was maybe your co-founder say in an interview, like, what we're actually selling at some level is measurement and verification. Like, is that kind of certainty that companies are paying us for. That's very interesting to me. It's a little abstract, but I find it really compelling.
Absolutely. One of the reasons why Peter was interested in starting Charm with us was this idea
Peter,
that...
your co-founder.
Yeah, my co-founder, Peter, he previously ran an organization called Segment. And at Segment, he was trying to find a way to purchase carbon removals. And he is a character who will dig in on a problem if he starts to see something a little bit strange. And so he started going deeper and deeper into these carbon removal projects and was just like, none of these seem additional. None of these seem... Sure, they have a gold star from this.
None of them seem totally legit.
Pay-to-play organization. Yeah. And so he's like, where's the permanent carbon removal? Because the extraction of oil and burning it is a permanent carbon addition currently.
Yeah.
We are one of a handful of companies that are actually offering a permanent removal. And that's sort of what separates Charm in the industry.
So, it's obviously more compelling than somebody who says, I won't chop down this tree. It's also, at this point, just absurdly more expensive, right? It typically doesn't cost much to not chop down a tree. It costs a lot now to do what you're doing, right? How much does it cost now? And what do you need to get to for it to be, realistic at scale?
It costs Charm just about $600 per ton of CO2 equivalent removed from the atmosphere. And that is the current price to remove carbon permanently.
Just give me some feeling for how much a ton of carbon is. How much carbon does one American emit in a year,
It's about 15 tons per U.S. Average person per year.
15 per person per year, and your cost right now is $600 per ton.
Per ton.
So it's way too expensive for now, what you do. Like, it's not gonna go anywhere at that price, right? But like, presumably part of your iterative thing is making it much cheaper really fast, which is a thing. Iteration and technology is is good at, right? It kind of invented that move.
Exactly. I think that it's a fair criticism to say it's extremely expensive because it is. And that is just the cost to deliver it right now. And so the
Yeah.
major price points in that cost are things like the cost of baling and moving that biomass to the side of the field and all of the
Okay.
labor associated with that, the transport of biomass, the fertilizer replacement. If you're removing that biomass from the field and you're not leaving back those nutrients, the farmers still need to replace that.
So it's $600 a ton now. It's too expensive. What do you want to get it to in the medium term? What, you have a number in your mind?
Yeah, in the medium term, we need to get it below $300 per ton, give or take,
Okay.
which gets us into the non-voluntary markets. It's the cap and trade in the U.S. Like the way the U.S. has
Okay.
decided to.
So people in places like California and Europe are actually paying $300 per ton now by under various laws.
Yeah,
So when you think about cutting your price in half, are there a few key steps?
I think the big thing in the near term is reducing the amount of operators and the amount of infrastructure needed for these sites. So the big thing that we've done from the start at Charm is focus on automation. And so we're trying to say from the start, what is everything that we need instrumented on this machine to be able to control itself, to be able to monitor these processes. And in the same way that you take a satellite and put it into a safe mode, if something goes wrong with this machine, it enters a safe state.
So, I mean, I know it's like a super prototype, but basically, how many people do you need to run it now?
Currently, it takes 2 operators. We really do 3 because we have someone whose job is just to look at data that's streaming off the machine and sort of keep an eye on sort of over the shoulder.
You want to get it from 3 down to 1? I mean, is that the basic idea?
I think we want to get it down to less than 1 is the dream. And so you have maybe a person monitoring 5 or 10 of these machines.
And your model for that is already there in like modern farm equipment, right? There are these giant machines called combines that are highly automated and that show up at harvest time every year.
Yeah, and so when you look at the way that these combines are currently used in the field, is a farmer doesn't own one of these pieces of equipment. They're $1 million plus. But instead, there's a group that comes through with 10 of them every harvest time and is just moving from the south to the north, going through, following the harvest and removing processing the field. And so,
I mean, combines, to be clear, are just machines that harvest wheat, corn, that kind of thing, right? It's just a giant machine that does that.
Harvesting piece of equipment. Yeah.
Yeah.
And so we are harvesting oil from the field effectively. So we're following that harvest. And so it aligns well with the current way that the market is moving to have these sort of fleets of contract harvesting operations. And so we see ourselves either partnering with or following one of those harvest operations.
Who are your customers?
Our first customers were Stripe, Shopify, Microsoft. It's companies that are trying to catalyze this industry.
There was this basically an advanced market commitment, right? From a group of companies led by Stripe, where they basically said, we're going to spend $1 billion on carbon removal.
Frontier Fund. Yeah.
The Frontier Fund.
We think overall it's a huge thing for the industry because there's so many technologies in the carbon removal space that get to either a pilot plant or like a slightly larger scale, and then they need to scale up to be productive. And so people build something on a lab bench, and then they try to build the $200 million plant, and they can't raise funding for that. And what the industry has done in the interim is that groups like Stripe and Microsoft, Shopify, the Frontier Fund have gone out and said, we will guarantee offtakes from these facilities. And so now people looking at building a $200 million plant can actually raise debt financing by saying, we have guaranteed offtakes over the next 10 years. And before these advanced market commitments existed, if you went to a bank or you went to an investor and you're like, hey, I need $200 million to build this plant. And they're like, cool, who's going to buy it? And it's like, well, a bunch of people bought some stuff last year.
Yeah.
And it's like, is anyone going to buy anything next year? And you're like, I don't know. And so you can't, that's not, to throw it back to economics, that is not a standard investing structure that would make sense.
I mean, I get ultimately that we need to both reduce emission and pull carbon out of the atmosphere. It does seem like in the interim, getting better at pulling carbon out of the atmosphere could reduce the sense of urgency with respect to lowering emissions, right? I'm sure this is a thing you think about. Like, what do you think about it?
I think that our built world is engineered around fossil fuels currently. And so there is no rapid cutover. I think that it is a yes and. We're not going to overnight convert all aircraft into running on renewable fuels. We're not going to be able to upgrade all aircraft to hydrogen in the next few years, but that will happen on the horizon, and it will happen through incentives, and it will happen through regulatory as well as pushing these markets. And so I think that Charm is not in the business to extend the sort of life of oil and gas assets. What we are doing is extracting carbon from the atmosphere, and we're trying to do it as fast as we can and get to a scale that once we are already past an oil economy that is running our little civilization on this blue marble, we need a way to be extracting carbon from the atmosphere quickly. And that is what we're trying to build. And so I see the sort of carbon credit markets as a tool that allows us to scale versus something that allows that industry to perpetuate.
In a minute, we'll close the show with the lightning round. Shaun spent 2 years living in Antarctica. I got a few questions for him. Now, back to the show. Let's do a lightning round. Let's do a bunch of questions. Some of them are going to be about Antarctica, but not all of them. We'll put the Antarctica. Antarctica will be its own continent within the lightning round. In your Twitter bio, you call yourself a hardware hacker. I'm curious, are there like household objects that you've hacked?
I turned a microwave into a puzzle for a friend's wedding recently. It had a car horn in it, and it looked like a microwave from the outside. But he's someone who hates buzzers, and so it was he loves puzzles, he hates buzzers. I thought it was a great little thing.
What's one thing I should do if I ever find myself in Augusta, Kansas?
I think the barbecue in Kansas is great. I wouldn't turn anyone away from that.
Do you have like a guilty carbon footprint pleasure?
Yeah, I enjoy traveling. I enjoy meeting people in different places. I spent 2 years at the South Pole, which ran on diesel. I'm still trying to offset that one.
So let's do a little lightning round within the lightning round about your 2 years at the South Pole, because it's amazing. Like, what? By the way, what were you doing there? When were you there?
I went down at 18 to shovel snow.
And you came back at 20, tired of shoveling snow?
Yeah, exactly. No. I went down at 18. I was, ostensibly to shovel snow, but I ended up working with the Ice Cube Neutrino Observatory on their deployments. And I was just hanging out in the comm shop during the summer, like fixing electrical things. That's been my...
Comm? What is comm?
In the communications shop, in the radio shop. And the person who was supposed to win her over for the communications role was deemed not physically qualified, and they kind of turned to me and they're like, "Hey, you have a pulse and like to fix things. Do you want to stay on as the senior communications technician for the South Pole?"
For the winter.
Sure. For the winter. The last plane leaves in February and the first one doesn't come back until November.
Let's do a little overrated or underrated. Overrated or underrated 6 months of darkness?
Underrated.
Underrated. It's better than I think.
When you walk outside, it's not just dark, but the auroras are directly overhead. So you can be walking under starlight and then all of a sudden everything turns green and purple. And You look up and there are just ribbons of light dancing across the sky. And it is unbelievably beautiful. Still one of the most beautiful places I've ever been.
Underrated or overrated 6 months of sunlight?
Overrated. we call it the hell star down there, because you walk outside and it's just always up.
The sun, and so you're walking. To be clear, the sun is the hell star.
Yeah. It's, you go out to the bathroom in the middle of the night, right? And it's, 1, 2 in the morning, and there's just a sun blaring down on you. Because in the summer, you stay out at summer camp, which is a bunch of tents, effectively. And so with no bathroom in the tent, so you have to walk over to the bathroom site, and it's cold and it's bright. And yeah, I don't know. I think it's overrated.
Good. Interesting.
Sunshine overall, not overrated, but 6 months, definitely overrated.
How do you feel about ice?
I love the sound it makes when you walk on it. And the way that I think you would have a great time down there with a mic. It is the sound of the ice crystals blowing across the polar plateau is unreal. And you're at about 10,000 feet on top of a 2-mile thick glacier that's moving 33 feet a year. And so it doesn't snow at the South Pole. We get less than 1 millimeter of precipitation a year. It's drier than the Atacama Desert. And so the only snow that's coming in are these like little ice crystals that are broken down snowflakes that have been blowing for hundreds of miles across the vast openness of the 7th continent.
That's cool.
It's really cool.
Shaun Kinetic is the co-founder and chief scientist at Charm Industrial. Today's show was edited by Robert Smith, produced by Edith Russello, and engineered by Amanda K. Wong. I'd love to know what you think of the show, and in particular, I have one request. Send us one thing you'd like us to change about the show, one way we could make the show better. You can email us at problem@pushkin.fm, or you can find me on Twitter @Jacob Goldstein. We'll be back next week with another episode of What's Your Problem?